Printable Science presents a 3D printable electroscope. Wikipedia tells us that the electroscope is an early scientific instrument used to detect the presence and magnitude of an electric charge, and you are encouraged to refer to the Wikipedia entry to learn more about the history of the electroscope and the physics behind its operation. You can make this electroscope with your 3D printer, a clear glass jar, some aluminum foil, and some glue. For tools, you should only need a sharp blade like a box cutter or X-Acto knife and a ruler to serve as a cutting edge and burnisher. You may also have the need for a file or some sandpaper to clean up some of the printed parts. An electroscope is composed of 5 component parts: a collector serving to accept any externally applied charge, a leaf assembly to show the effect of the charge, an electrode to transmit the charge from the collector to the leaf assembly, a jar to enclose and protect the delicate leaf assembly from damage and transient charges that may affect its operation, and finally a lid or some other mechanism such as a stopper to secure the collector electrode leaf assembly to the jar. Our 3D printable electroscope is composed of 7 pieces in 2 STL files that make up the required components for our electroscope. The collector is a single printed piece that you will glue some aluminum foil to act as a conductor for an electric charge. The leaf assembly is also a single printed piece that you will supplement with 3 pieces of aluminum foil. For the purposes of assembly, we refer to the printed piece as the hanger. The electrode is composed of a piece of aluminum foil and 2 printed plastic pieces which bookend the aluminum foil and serve to give support and strength to the aluminum foil. For our electroscope's jar, we use a pint-sized regular-mouthed mason canning jar. The 2-part closure system consisting of the band, or screw top, and lid is convenient as we only require the band and the lid can be discarded. 2 popular brands of mason jar are Ball and Kerr, and you should be able to pick those up at any grocery store, Target, or Walmart. When shopping, you simply want to ensure that the jar has as little embossing as possible, as you will want an unobstructed view in order to see the leaf assembly as it is working. Kerr jars seem to be dependably less ornamented than the Ball jars, and if you have difficulty locating this item, you can order one from printablescience.com. You can use any clear glass jar that has a mouth opening smaller or equal in diameter to the lid printed part, 66 millimeters, or 2 5/8 inches, and either rest or glue the electroscope's lid to the rim of the glass jar you use. The first step is to print the required pieces. As mentioned previously, there are 2 STL files, and at 4 millimeter resolution, this will take around 2 hours to print all the required pieces. Once you have removed the parts from the printer, the first step is to ensure that the electrode fits snugly into the collector, the 3 pieces of the lid, and the leaf assembly hanger. There should be no need to remove material from inside any of the non-electrode parts, unless, of course, your printer has left a gob of plastic or some other obstruction while the part was being manufactured. Any necessary adjustment can be achieved by filing or sanding the electrode pieces, concentrating on removing material from the exterior outside rails only. You may be lucky and discover that no adjustment is required at all. We've printed numerous copies of the electroscope and find that about 80% of our yield can be assembled with no additional modification. The next step is to cut the required pieces of aluminum foil. Many other electrodes use a variety of materials such as copper and brass in their construction, but in keeping with Printable Science's design philosophy of a low material count and simplicity of construction, this version of the electroscope uses aluminum foil exclusively as a conductor, where others might use a variety of other materials to achieve the same effect. The purpose of the aluminum foil is to serve as a conductor for our collector and to provide an electrical connection from the collector through the electrode to the leaf assembly at the bottom of the electrode. We will require 5 pieces of aluminum foil. The first piece we cut is the large piece for our lid. This piece is entirely cosmetic, and if desired, you may skip this step. To cut it, use the bottom piece as a template. Place it over the aluminum foil, and then using a sharp knife and while applying pressure to the part, cut around the aluminum foil using the lid as a guide. It is very important to use a sharp knife when cutting. You'll find that when cutting aluminum foil, there is a sweet spot with respect to the pressure that's required. Too little and you won't cut through the foil. Too much and the foil will shred rather than cut. The more pressure you use to hold the template in place, the greater your sweet spot will be, allowing you to apply more cutting pressure without fear of shredding. Fortunately, aluminum foil is very inexpensive, so you can make lots of mistakes while learning how to cut aluminum foil like an expert. After cutting the large circle, you'll need to cut a rectangle in the center of it, slightly larger than the size of the electrode. Note that this piece of foil we are cutting is for cosmetic purposes only, and when assembling this piece, the foil should not touch the electrode's aluminum foil. The next piece of aluminum foil to cut is for the collector. As with the lid, use the printed collector piece as a template when cutting out the required piece of foil. Next, we cut the aluminum foil for the electrode. We double the thickness of the foil by folding it over. Then, using one of the printed electrode pieces, placing it along the edge to give us a guide for the width of the foil we need, we then place the ruler up against the side of the electrode piece, remove it, and then cut along the ruler to create our electrode conductor. Next, we need to create a wire-like facsimile for hanging our leaves off of. We take a piece of aluminum foil and fold it over 3 or 4 times and then burnish the foil with the end of our straight edge to ensure that the foil is very tightly folded. Then, using the straight edge or ruler as a guide, we cut a very thin piece off the edge. As you can see in the video, we missed the sweet spot for this assembly and failed to cut through all the layers of foil in one go, but we were able to cut it free eventually. The last piece of aluminum foil we require is for the leaves. One of the printed pieces you produced is a template for the leaves, and as we require 2 leaves, we fold the aluminum foil over and using the template as a guide, we cut the required pieces. Now that we have cut all the required pieces of foil, we can move on to assembly. We begin by constructing the electrode. We take the piece of foil cut for this purpose and sandwich it between the 2 halves of the electrode. Note that the electrode has a square end and a curved end. The straight ends should both be together. While holding the electrode together while the foil is sandwiched in between it, take the electrode collar, the circular piece with no lip, and slip it over the aluminum foil conductor and the 2 pieces of the electrode. Then square up the electrode assembly by pressing the square end of the electrode onto a flat surface. Next, we fit the collector in place, threading it over the foil of the electrode and slipping it onto the flat edge of the collector. Folding the foil flat against the collector allows us to square up the assembly again by pressing the electrode and collector against a flat surface. At this point, the electrode foil overlapping the collector should be glued into place. You should avoid getting any glue on top of the electrode, as most glues are insulators and will prevent a proper electrical connection between the collector foil and the electrode foil if the glue gets in the way. Now we can apply the collector foil by adding glue to the collector surface, except where the electrode foil is placed. Then we simply press the foil onto the collector and then ensure that it is firmly affixed by pressing the collector with the glued foil attached against a flat surface. The next step is to position our lid onto the electrode, making a sandwich of the top part of the lid, making sure that the printing is right reading. We take the large piece of cut foil, which has the rectangle cut out of its center and shiny side up, and then the lid bottom. We press this onto the electrode until it presses up against the lid collar we initially installed. The next step is to construct our leaf assembly. We can begin by cutting a shorter piece of our leaf wire to a size more closely matching the piece we need. Then, after we fold the electrode's foil over the curved end of the electrode, take the piece of very thin foil and use the curved end of the electrode to form a loop. Now, we thread the leaves onto the looped wire we have just formed. If necessary, we can enlarge the hole in the top of the leaves to make it large enough to slip easily over the looped section of wire. In the video, our two leaves are still stuck together, but this is not essential for construction. If your leaves have become separated, you can simply install them onto the loop foil one at a time. The ends of the foil loop from which the leaves are hanging are inserted into the hanger printed part, and the whole subassembly is then pushed onto the bottom of the electrode. The important thing to note is that the thin wire needs to make good contact with the electrode wire, so there is a good electrical connection all the way from the connector through to the hanging leaves. Once the leaf assembly has been secured, it's a good time to trim back the ends of the loop wire. Once that has been accomplished, and if the leaves were not separated before being threaded onto the foil, now is the time to do so, as demonstrated in the video. If you have not done so already, this is a good time to trim any extra electrode foil that extends beyond the side of the collector. Finally, it's just a matter of removing the band from the jar, placing the electroscope lid over the top, and screwing the band closed. To test your electroscope, you'll need to generate a static charge, which is easy enough to do from a variety of materials you'll find around the house. You'll want to check out the Wikipedia entry on the triboelectric effect. The right-hand side of that web page provides a listing of materials that can be used to generate a static charge through friction. The method is to use any two materials in the series as far apart from each other as possible on the triboelectric series table. In the video, we are using PVC pipe and polyester, which are not particularly good choices, but still adequate enough to create sufficient charge to force the leaves apart on the electroscope that we have just constructed. The latest files and forum on the 3D printable electroscope are available on the printablescience.com website, where all the science that fits, we print.